This video is about solving absolute value equations and inequalities. The absolute value of a number is its distance from 0, and that distance is always positive. So if you have the number 7, for example, the distance of 7 away from 0 is 7 units, but the distance of negative 7 away from 0 is also 7 units. So we would say that the absolute value of 7 is 7, and the absolute value of negative 7 is also 7. So absolute value equations have two solutions. There are two values for x that are going to make the sentence true. So in this example here, we have x minus 4 inside of the absolute value symbols equals 7. This does not mean that you make that x plus 4. It's a very common mistake that I see. You don't just change everything inside the symbols to a positive. What it means is that when you plug in a number for x and then subtract 4 from it, then you would take the absolute value of that and have it come out to 7. So basically what we're saying here is that this whole expression inside could either equal 7 or it could equal negative 7. Because when you put it inside of the absolute value brackets, both of those will come out to a 7. So to solve this equation, I'm going to solve this one mentally just to illustrate the point here. We know that 11 minus 4 is going to equal 7. And when you take the absolute value of a 7, you do get 7. So one of the values for x is 11. But there's another value for x that works. So what value could we plug in for x there that would give us a negative 7? And that number is negative 3. So negative 3 minus 4 would give us a negative 7. But then because it's inside of the absolute value symbols, that would also yield a 7 as our solution. So both of these are solutions to this equation. So that you don't have to always guess and check, I'm going to show you the quickest method to solve an absolute value equation for both solutions. You have to actually solve it twice. So drop the absolute value symbols and solve it once, coming out to 35, and solve it a second time, coming out to negative 35. So notice I did not change the left side of the equation at all. I changed the right side of the equation, keeping it positive in one of my equations and turning it negative in the other equation. Solve both of these using inverse operations. So 10x equals 40, x equals 4. On this side, when we add 5, because that's a negative 35, we get a completely different solution, right? It's not just a negative version of the other solution. We get two completely different answers. These are both solutions to the equation, and you can plug them back in to check to prove to yourself that they will both give you a 35 after you plug them in and take the absolute value. When the variable is both in and outside of the absolute value symbol, it gets much trickier. Now you might get something called an extraneous solution. It's a solution that you get by solving algebraically, but that turns out not to be valid because of the way the original equation is written. So you're going to discover this by plugging both of your answers back in to check them. So this is the first time it's really become mandatory that we check our answers, because some of them are actually going to end up being bad answers that we're going to have to throw out. So when I solve this equation, we're solving it twice, once exactly as written without changing a thing. The second time, remember to keep the left side of the equation the same and distribute a negative through the right side of the equation. So we're solving it once with a 4x, once with a negative 4x. To solve these equations, get the x to one side, so x equals 3. This one's different because it has a negative 4x. This time x equals negative 1. Now we need to check both of these solutions because the x in the original equation exists both inside of the absolute value symbol and outside of the absolute symbol, right? Absolute value symbol. It's here and it's here. So I'm going to plug both of these answers back in to the original equation, the one with the absolute value symbols around it. Plug in a positive 3, which is the answer we got over here. You have to plug it in on the left and on the right because the x exists in both places. So let's finish simplifying this one. 2 times 3 is 6. 6 plus 6 is 12. The absolute value of 12 equals 12, and that is true. So this is one of the solutions. I'm going to go ahead and circle it. Again, back to the original equation, plug in the second solution that you got, which was negative 1. 2 times negative 1 is negative 2. Negative 2 plus 6 is 4. Equals, and simplifying the right side of the equation here, we have a 4 times the negative 1, which is negative 4. Does the absolute value of 4 equal negative 4? Absolutely not. And so this is an extraneous solution. It is necessary for you to show all of this work, show yourself checking it in, and then go back to your answer and cross it out or somehow indicate that it's an extraneous solution and it is not part of the solution set for this equation. Here's another slightly more complicated example. We're going to leave the left side of the equation the same, keeping the right side the same for our first equation, changing the right side for the second equation. Notice I changed both the 2x and the 9 to being negative. It's like I'm distributing a -1 times the entire right side of the equation. Solve both of these equations. On this side, x comes out to +5. On this side, x comes out to -4/3. It's okay to get fractions as your answers. And yes, it is necessary to check both of these solutions because in the original equation, we have x inside and we have x outside. I know it seems tedious, but if I'm going to do the work, then you have to also. So we're going to plug in both of these to figure out if either one of them is extraneous. On the left, I get 20 minus 1, which is 19. 2 times 5 is 10, plus 9 is 19. Is the absolute value of 19 equal to 19? Yes, it is. So this is one of the solutions. Now, it's not always true that only one of them works. So you do have to check both of them, even if your first one works. The second one might also work. So let's find out. We have a 4 times a -4/3 minus 1. 2 times -4/3 plus 9. Simplify the left side, we get -16/3 minus 1. I'm going to change that to -3/3. On the right, we have -8/3 plus 9, which I'm going to change to 27/3. Notice I'm getting common denominators so that I can simplify both the left and the right side of this equation. This comes out to -19/3 inside of the absolute value symbols. It's not the prettiest number, but it is what we got. On the right, -8 plus 27 on top is +19, denominator is 3, and is the absolute value of -19/3 equal to +19/3? Yes, it is, and therefore this is also one of the solutions. So both of the answers worked this time. It's a very simple example here. What about this? Can the absolute value of 2x minus 8 ever equal -50, no matter what you plug in for x? And the answer is no, because when you take the absolute value of something, it's going to come out to a positive number. As soon as you see an equation like this, you write no solution. There is absolutely nothing you could plug in for x that would result in a -50 coming out of the absolute value symbol. So always be on the lookout for this. Look for it first so you don't end up doing a bunch of unnecessary work. If an absolute value equals a negative, that's a trick question, and you write no solution. Absolute value inequalities are very similar to the equations, but when we solve these, we're going to change the sign of the right side of the equation like we've been doing and the inequality sign in our second equation. So it still has two solutions. If the absolute value of x is greater than 9, think about what x could be, right? X could be something like 10, 11, 12, 13, 14, because the absolute values of those numbers are greater than 9. But x could also be things like -10 and -11 and -12, because the absolute value of those are also greater than 9. So to show the solution to this, we want to write that x is greater than 9 is one of the solutions, and x is less than -9 is the other solution. So notice I have changed both the sign of the right side of the equation, positive becomes negative, and changed the inequality sign. Greater than becomes less than. So both of these are the solutions to this inequality. Just to work out a slightly longer one, keep one of the equations or one of the inequalities exactly the same. The other one, remember to change the sign and the sign of the number. Solve the inequality. On one side, we got x is less than or equal to 5. On the other side, we got x is greater than or equal to -6. Remember that if you're ever dividing by a negative, that you have to change the sign again. We don't have that here, but it might come up on your worksheets or your homework, so pay attention to that. And then just look at your final answer so that we can write it in the proper notation. We have x is less than or equal to 5, which means it could be things like 4, 3, 2, 1. And x is greater than or equal to -6, which could be things like -5, -4, -3, -2. Those two expressions are going to come together, right? So because there can be a single value for x that meets both of these requirements, this is an and inequality or a conjunction. And we want to write it in the proper notation. So the conjunction notation is to put x in the middle. It is higher than -6, right, or equal to. It is lower than or equal to 5. So we're going to put our x in the middle with our lower value on the left and our higher value on the right. This is the proper notation for a conjunction inequality. What about these? Again, these are the trick questions. If you look at the one on the left, if you plug in something to the absolute or to x inside of those absolute value brackets, will the value of it ever come out to be less than a negative 50? Well, less than a negative 50 would be things like negative 60 or negative 70. And there's no way for absolute value to come out less than a negative number. So this one is a no solution case. The second one, the most interesting, it says the absolute value of 2x minus 8 is greater than negative 50. Well, the lowest thing that the absolute value will ever come out to is 0, right? Everything higher than 0 and including 0. So are there any possible instances where this won't come out to be greater than negative 50? And the answer is no. No matter what you plug in for x, this is going to be a true statement. So in this is one of those cases where we want to say that x is all real numbers, right? That symbol means all real numbers, because any real number that you can think of to plug in for x is going to work in that inequality. And that is all.